Okay, so this one we're doing live. We're doing it live. Hopefully this will be good. Wait, what just happened? The one we... Okay, right. Warts and all. Warts and all in this one. Okay, so find the next perfect square. You might know some pretty large perfect squares, but what about the next one? Complete the find next square method that finds the next integral perfect square after the one passed as a parameter. Recall that an integral perfect square is an integer in such that square root in is also an integer. If the parameter is itself not a perfect square, the negative one should be returned. You may assume the parameter is non-negative. So the next perfect square after 121 is 144. 625 is 676. 114 goes -1 since 114 is not a perfect square. Okay, cool. So first we need to determine if the input is a perfect square and then increment up to the next one. So if squa, so if math dot sqrt, gosh, modulo 1 equals 0 gives us the remainder of integer, the remainder of the division of this, and that should equal 0 if it's an integer. Otherwise, if it's a decimal, it'll be more than 0. Okay, so if that, then we're going to loop up to a value that's actually we probably need a while loop. So we want this might be a weird one, but we want to loop while so we're going to be taking the square and incrementing it, and then once it equals a number whose square root is integral perfect square is an integer such that its square root is an integer. Okay, so we're going to increment it until its square root is an integer, right? But since that is already true, since this is in this if block, that will already be true. So we need to add 1 to it. Whoa, what did I do? So while this, no, we need to, okay, I'm gonna make a variable for this, okay? So this is my, okay, so my starting square will be, we'll just call this square. Not a very good variable name, but we're just algorithming right now, so it's all good. So it'll be this plus 1 to start us off. Okay, so while my square is less than, or if my square, as long as my square is not an integer. So we're going to do the same thing we did above, except we want it to be not equaling, right? All right, cool. And the first thing I want to do is increment square by 1. All right. Okay. No. That's not the first thing I want to do. That's the last thing I want to do because I've already added 1 to it at the beginning, right? So while it's not that, I just need it to increment. That's really it. And then once it does hit that number, I need to return it. It sounds like, so I'm not really familiar with do while, so I'm going to cheat and look this up actually. This sounds like a job for do while. Executes a specified statement until the test condition evaluates a false. The condition is evaluated after executing the statement, resulting in the specified statement executing at least once. Wait. Until. Okay, that's not really what I wanted. Okay, so what's going to happen is if the square root is an integer or if it's not an integer, it's going to be incremented. So what do I do if it is an integer? If it is an integer, this isn't going to do anything. And we're going to return the square. Yeah. Okay. Yeah, that's what we had to do here. I'm curious. Expected 12 to equal 144. I don't know how that could possibly happen. So we're taking the, oh, I see. Return we need to just return SQ plus 1. That would be our answer here. Yeah. So, okay. So it's failing at 121. 121 should be outputting 144. So square plus 1. Okay. So this should be named root. I've confused myself with my naming scheme. This is why you oh no. Oh no, okay. My arrangement is just off. Okay, so I need this to be SQ plus 1. And then I need to take the math square root of this here, right? So now I'm just finding out if the square root is not an integer. And as long as it's not, we're going to increment the square. right? And then once that's done running, we return the square, right? Yes. Okay. Cool. All right, so let's attempt. Oh, cool. Okay, so what do we do here? I'm not sure what I could do besides... Yeah, I'm gonna just take a look at our the other answers here. Oh, a ternary. Of course. Wait, okay, they're doing square root. Oh, do I even need I don't even need the equals 0, huh? -1 or return plus 1. Two. Plus 1 squared. Square root plus 1 squared. I'm not sure why this works. How... let's explore this. Okay, so find x square. So what exactly is happening? So we've got... I'm gonna put these into variables so that I can... Or put this into a variable and more easily print that off. No, what am I doing? Oops. I don't need to put that into a variable, I just need to console log it. Okay. I mean, okay. Didn't all right, so log's 144. Okay, so if our initial value is a perfect square, then if our initial value is not a perfect square, then it does this. And then if it is a perfect square, we're taking the perfect square plus 1 and squaring that, because that will be a perfect square. So 122, no, the 122, the root of that squared will be our next perfect square. Okay, I see. So the person who made this probably knows the math behind finding perfect squares, and that's probably the math behind it, which is, yeah, that's cool. Anyways, I guess I don't want to submit that as my answer. It's cheating. Okay. For that one,